Hi, everybody. Welcome to the fun and exciting world of currents and climate. That's right. All right, so we're actually going to talk about two major kinds of currents today. One is surface currents, one is deep currents or deep water currents. We're going to start with surface currents. And the basic idea, what is it? Well, a surface current is a large stream of water that flows through oceans. And while it does have some similarities to waves that we'll talk about in a few minutes, they are unlike waves in that the water actually goes from one place to another. It travels great distances. Remember with waves, the water molecules kind of moved in a circle, but they didn't really go anywhere. That's different from surface currents. In currents, the water molecules actually move sometimes thousands of miles. Um, Surface currents mostly affect water that is at the surface, but the surface in an ocean, because it's huge, can actually refer to water that goes down several hundred meters. Now, this is how surface currents are similar to waves in that surface currents are controlled or caused mainly by wind. Okay, so that's similar to our surface waves, but in this case we're talking about surface currents. This map here shows most of the major ocean currents in the world. You'll notice the red arrows represent warm water currents. The blue arrows represent cold water currents. You may also notice that there are a lot of kind of circular type shapes in these currents. We see it in the South Pacific. We see it here in the South Atlantic. We see it in the North Atlantic going this way, the Indian Ocean. So there are a lot of circles. Well, why do they move in circles? The biggest reason is because of the Earth's rotation. So we all hopefully realize that the Earth rotates on its axis. It goes around once every 24 hours. That's what makes our day. Well, as it turns, it causes the winds that are blowing on the surface of the Earth to curve. And when the winds curve, the winds are affecting the currents, so the currents also curve. So when this curving happens, that effect is what we call the Coriolis effect. Okay, the Coriolis effect is the effect of the Earth's rotation on the direction of winds and currents. That should say at the bottom, not our currents, and currents. All right, here you can see typically the wind might go in a straight line, except for when the Earth curves, or when the Earth turns, it causes it to kind of curve around. Same thing in the southern hemisphere, the wind would go this way, or this way, excuse me, but instead it curves to this direction here. So you'll notice it curves in the opposite direction in the northern hemisphere as compared to the southern hemisphere. Here we see some other examples of how the wind blows and how the Coriolis effect has an effect on the winds. This shows the major winds of the world. We'll get into that a little bit more another time, but hopefully it shows you a little bit of why we have these circular patterns in our currents. The most powerful and largest surface current in the North Atlantic Ocean is called the Gulf Stream. Now, when we watched the videos there about the ocean mystery of the shoes and the oil and things like that, the Ocean Odyssey video, they talked about the Gulf Stream. It's a really large surface current that flows off the eastern coast of the United States. It doesn't come all that close to Maine and New Hampshire. If it came a little closer, we'd have a little bit warmer weather. All right. And that is caused because of strong winds that come from the west and blow across the ocean. Here's a map that kind of shows that warm current flowing through the Atlantic Ocean. Again, if it could get a little bit closer up here to Maine and New Hampshire, our water would be a lot warmer in the summer and we'd have a lot warmer temperatures year round, so we'd probably have a lot less snow and ice and all of those types of things. Instead, what we have over in this area here is what's called the Labrador Current. It's not as powerful. You can see this very strong stream of warm air that is known as the Gulf Stream. And as I mentioned a few minutes ago, currents are related to the climate that we have. Climate, of course, is the pattern of temperature and precipitation in an area, essentially the pattern of weather over a long period of time. As currents move near land, they affect the temperature of the air above the current, above that water, and so that therefore affects the temperature of the land that's nearby. So currents affect climate by moving cold and warm water around the globe. And the currents can move warm water from the tropics to the poles and can also move cold water from the poles toward the equator. So a surface current warms or cools the air above it. Like I said, that influences then the climate of the water that is nearby, or of the land that is nearby. All right, so we've talked quite a bit here about surface currents. Let's take a look at deep currents or deep water currents for just a moment. Well, okay, a few moments. All right, so at the bottom of the ocean, we have these deep currents. And these deep currents are causing water to again move. So we've got water molecules that are moving from one place to another. And these big rivers of water down there creep pretty slowly along the ocean floor. In fact, they creep so slowly that it would take a very long time. In fact, we'll see in a minute, about 1,000 years in theory for a water molecule to go all the way around the world. These deep currents are not caused by wind. Okay, surface currents caused by wind, kind of like surface waves. Deep currents are caused by differences in density. So dense water sinks or less dense water rises and it causes a movement in water. So as temperature decreases, as water gets cold, it actually gets saltier. Okay, and then that cold and salty water is dense and so it begins to sink. That water then kind of flows along the ocean floor and that's a deep water current. So you've seen this picture before in your textbook. This is the Great Ocean Conveyor Belt. The blue parts are those cold, deep water currents that are creeping along the bottom of the ocean. And as they either reach a warmer area or as they kind of almost hit up against land, they begin to rise and become warm and travel along a little bit closer to the surface. They don't become surface currents, but they do travel a little closer to the surface than the cold water current. All right, so I think I mentioned a few minutes ago, deep ocean currents flow more slowly than surface currents. Surface currents flow pretty quickly, but deep water currents can take up to 1,000 years to make that round trip from the pole to the equator and then back again. All right, another aspect of these deep water currents is this idea of upwelling. You've read a bit about this. So upwelling is when that deep water moves up closer to the surface. That cold water that was down deep moves up closer to the surface. So in this diagram here, we see, and I kind of wish this arrow wasn't in red because it kind of makes it seem like it would be warm water, but that's not entirely true. So we've got this deep current here, it kind of starts to run into some land. This causes the water to rise, and then it starts to flow a little bit closer to the surface of the water. As it does, it brings nutrients up with it, which is great for fish, which is a lot of times why we see a lot of really good fishing near a continent or near the edge of a continent. So, as I mentioned a moment ago, upwelling brings much needed nutrients up to the surface of the water. And because of this, there are a lot of times they're great places for big schools of fish. All right, last couple of things. We're just going to take a quick look at another aspect of climate. Currents can also, ocean currents can also affect something called El Nino, and then there's also La Nina. Yes, these are Spanish words, means the boy and the girl. I can't really tell you why they named it the boy and the girl, but anyways, we're going to start with El Nino. El Nino is kind of a strange short-term climate change event that happens every 2 to 7 years out in the Pacific Ocean. And it can often cause a lot of really destructive weather. There tend to be, during these periods of time when El Nino is happening, tend to be a lot more flooding and hurricanes, tornadoes, forest fires, things of that sort. Being able to predict when El Nino is going to happen is really important because it enables people to be able to prepare for dealing with these weather events and destructive weather events that may come their way. We can't totally predict it at this point, but we can often predict it at least a little bit in advance. We can say that there are some years of El Nino coming up soon or something like that. So a lot of scientists and public officials use this bit of prediction that we can do in order to prepare and get emergency services ready. All right, well, ladies and gentlemen, I hope you guys are having a great day. I will be seeing you on Monday, and just to give you a little hint, we are going to be starting to review for a test over oceans that will be coming up not this coming week, but it will be happening at the beginning of the week after. So right now I anticipate that it will not be this coming Monday, but it will be the Monday after that. So ladies and gentlemen, here it comes. Get yourselves ready, okay? All right, I'll see you on Monday, guys. Have a great weekend. Bye.